Good day, students. Welcome to part 3 on adding and subtracting rational expressions. We're going to be going over 2 examples. So let's go ahead and write down the instructions for the examples we're going over. Find, again, find the sum, find the sum or difference, the sum or difference of the following rational expressions. Okay? The following rational expressions. All right, so example 1, let's consider this example where we have 3 divided by 2x squared plus 5x minus 3 minus 2x divided by 2x squared plus x minus 1. All right, we notice that the denominators are different. We need to have common denominators before we can add or subtract. All right, so in order to find the LCD, I don't know that these two polynomials have a common factor in them. So I need to factor both of them first and then determine what the LCD is without repeating common factors, okay? So what I'm going to do is I'm going to extract the left denominator, take out the left denominator, The left denominator is 2x squared plus 5x minus 3. So what I'm going to do is I'm going to factor this completely as best as I can. The first thing I'm going to do is I'm going to break it down to see if there's any common factor I can take out from the whole expression. So 2 times x plus 5 times x minus 3. There's nothing that's common to all three terms, so I'll reassemble each term. So x squared plus 5x minus 3. This is not a difference of squares. It's not a perfect square trinomial, so I will resort to using the x game in the factorization of this quadratic trinomial. So make our x. AC goes on top, B goes on the bottom. AC is 2 times negative 3. AC is going to be negative 6, and B is going to be 5. All right, so what are the factors of 6? The factors of 6 are 1 and 6 and 2, 3. This is kind of tricky because these two pairs generate 5, so we need to be careful here. If I try the option 2 and 2, I think that should work. So 2 and 3. Let's see. So we need the numbers to add up to 5. We need the numbers to multiply to give you negative 6, and the numbers to add up to give you 5. So does this work? How can we do the signs? This 2 plus 3 is 5. If I make any of them negative, it's going to resort to a bigger number. So this one actually doesn't work. So let's try another combination. Take this out. 2 and 3 doesn't work. Let's try 1 and 6. So 1 and 6. So since the sum is positive, that means that one of the numbers has to be negative, right? So since the sum is positive, the small one has to be negative. All right, so we're going to take these two numbers and put in here, so we can factor by grouping. So we have 2x squared minus x, or you can say 1x plus 6x minus 3. All right, so break everything down. 2 times x minus x plus 2 times 3 times x minus 3. All right, so what we're going to do, let's break it down the center, and we're going to factor by grouping. Okay, so break it down right in front of this sign right here. All right, so let's take a look at the first two. So we're putting it down in the initial step. So if I look at the first two, what can I factor out from the first two? I can factor out x. X is common. So I factor out an x is as though divided by x. So factor that out. These two are gone. So I'm left with 2x. If I divide this by x, I'm left with a 1. On the right side, I'll take out what's common. Take out a 3. All right. Always bring down the middle sign. We have 3 in front, and I'm left with 2. of these three are divided by, you'll be left with 2x, and then minus 3 divided by 3 is 1. All right? Are we looking good? Yes, these two quantities are the same. So put them together, 2x minus 1 times x plus 3. So this is the expression that goes downstairs here. So we're going to have 3 over 2x minus 1 times x plus 3. Okay? Minus 2x. Now that we're done with the left denominator, we're going to shift our attention to the right denominator. Okay, so the right denominator is x squared, 2x squared plus x minus 1. All right, so to factor this, we know that we have to break it down first and check to see if there's anything that can be taken out. So let's go ahead and do that. 2 times x plus x minus 1. Nothing can be taken out, so reassemble it. 2x squared plus x minus 1. This is not a perfect square trinomial. This is not a square either. Well, this is a square, but this is not a square. So we're going to use the x again to figure this one out. So make our x again. And then AC goes on top, B goes on the bottom. In this case, AC is -2, and B is +1. All right, so let's make our T chart and see what works. Make our T. What multiplies to give you -2, which is 1 times 2, right? Because it's prime. So let's put it here 1 and 2. Since the sum is positive, the bigger number has to be positive and the small number is negative, all right? So that's going to give us 2x squared minus x, or you can put 1x if you want, minus x plus 2x minus 1, all right? So break it down the center and factor by grouping, all right? Break it down the center, factor by grouping. So we break down each term on both sides of our partition to see what we can factor out. So we have 2 times x minus x on the left side plus 2 times x minus 1 on the right side. On the left side, I can factor out an x. Take out an x, I'm left with 2x minus 1. And on the right side, nothing comes out, but I can factor a 1. If you can factor out anything, you can always resort to factoring out a 1. So we're left with 2x minus 1. So the factor sum of this, I'm going to write it on the side here, is going to be 2x minus 1, the two quantities that are in the parentheses, and then what's left on the outside times x plus 1. All right, so there you have the factor form. All right, so what I'm going to do is put it back in the bottom right here, 2x minus 1 times x plus 1. Okay, so there you have it. So now let's look at the denominators. If you look at the denominators, you notice that 2x minus 1 is common on both sides, which is good. So this has a 2x minus 1, has a 2x minus 1, and this has a 2x minus 1. So that's a common factor that they share. This has an x plus 3, so we need an x plus 3 on the right side. So on the right side, we have to attach x plus 3. On the bottom and on the top, this is as though we're multiplying by 1. When multiply by 1, it makes no difference, okay? X plus 3 top and bottom. So now we have an x plus 3 and an x plus 3. Okay, looking good. Everything on the left side is on the right side. Now, looking at the right side, we have to make sure that everything on the right side is also on the left side, the denominators, okay? So we're missing x plus 1 on the left side. So we need to include that in the top and bottom, x plus 1 on the bottom times x plus 1 on the top, like that. And then that works out perfectly, okay? So now we need to resolve the numerator. We can leave the denominators alone since they're both common. To resolve the numerator, we'll just distribute the 3 to both terms. Distribute it like that to those terms in this quantity. So we're going to have on the numerator 3x plus 3 divided by this third degree polynomial function, which is, we don't have to FOIL it out, it's x plus 1 times 2x minus 1 times x plus 3. On the right side minus, this 2x will distribute it to both of these two terms in the parentheses here. So we'll have 2x squared, because x times x is x squared, plus 6x. And then that whole business divided by the denominator, which is exactly the same as the denominator on your left. So it's going to be 2x minus 1 times x plus 1 times x plus 3. Since multiplication commutes, it doesn't matter the order of the products that we're writing, okay? Now we have to write both fractions as a combined fraction. So we want to write both of them as a combined fraction. So since both denominators are identical, we can write them as 1, which is x plus 1 times x plus 3 times 2x minus 1. All right? And then bring down this 3x plus 1 plus 3, sorry. And this is where you have to be really careful. See this minus right here? Whenever I have a minus in between two rational expressions, be sure that it is distributed to the terms on the right numerator. So this minus will be distributed to 2x squared and also to the positive 6x. So it's going to become negative 2x squared minus 6x, because minus times plus is minus, minus times plus is minus. All right, so let's simplify the numerator. Let's bring down the denominator because it doesn't change. We just did it just like that. So we bring down the denominator as it was before. We'll have x plus 1 times x plus 3 times 2x minus 1. And then in the numerator, if we simplify the numerator, we're going to have, let's combine like terms here. We have the square. 2x squared cannot be combined with anything, so we just bring it down, negative 2x squared. Next, we're going to shift our attention to the x's. So let me put a dot here. This x and this x, we combine them. Since their signs are the same, their signs are different, you're going to subtract and keep the sign of the bigger one. So if I subtract and keep the sign of the bigger, 6 minus 3 is 3. Since the bigger is negative, we'll have negative 3x. And then plus 3. Okay? And there goes your final answer. Okay? All right. Now we're going to do a real quick reflection on this whole procedure. And then we are going to move on to the next example. All right, welcome back. Now let's try number 2. So for number 2, we have, we're going to do the same process. We have 2x divided by the quantity 3x squared plus 8x minus 1 minus, in this case, on the right numerator, we're going to have a binomial expression, which will make the process a little bit longer, not too long, divided by the quadratic trinomial in the denominator, which is 2x squared plus x minus 15. Okay? Now we need to find the lowest common denominator. I don't know if they share a common factor, so I need to extract each denominator, factor them completely, introduce them, and then see how we can find the LCD. All right? So let's start with the left denominator. Okay, the denominator on the left denominator. All right, so the left denominator is 3x squared plus 8x minus 1. So we need to break it down first and see if there's a common factor we can extract. So 3 times x plus 2 times 2 times 3 times x minus 1. Nothing can be factored out, so let's reassemble it back as it was because there isn't any common term in all three terms, no common factor. So we have 3x squared plus 8x minus 1. Now we're going to look at this. This is not a difference of squares. It's not a perfect square trinomial because this is not a perfect square. So we're going to resort to using the factoring by grouping or the x game. Okay, so let's make our x. AC goes on top, B goes on the bottom. AC and B. So in this case, AC is -3 and B is 8. All right. Okay. This is a slight typo here. Let's do a real quick correction. Let's change our C. Our C was supposed to be 3. Let's change that so that changes AC. Sorry about this. This was supposed to be 3 right here. So let's make that 3. Make that 3. Make that 3. And make that 3. So our AC is going to be -9, or else we can factor it. Okay? Now we can do this. So factors of 9 are 1 and 9 and 3, 3. Okay, clearly the first pair works. So 1 and 9, since the sum is positive, that means that the smaller one is negative, all right? So let's reinsert that into the expression. We're going to have 3x squared minus x plus 9x minus 3. Okay, now we're going to break it down to center and factor by grouping, like this. Break everything down. We're going to have 3 times x minus x plus 3 times x minus 3. All right, what can we factor here? We can factor out an x from these two. Take out an x. We're going to be left with 3x minus 1. And then from this side, we can take out the 3. Always bring down the middle sign, plus 3 times 3x. If we take out a 3 from this 3, you're going to be left with 1. All right? So combine them together. These two are the same. We have 3x minus 1 times x plus 3. All right, so let's insert that as a left denominator. So we have 2x divided by the quantity 3x minus 1 times x plus 3 minus 5x plus 1. Now, we're going to have to factor out the right denominator to basically find the LCD efficiently, okay? So whatever process we did for the left numerator, denominator, we're going to do the same process here. So let's do the right denominator. Okay, right denominator. All right, so that's going to be 2x squared plus x minus 15. Okay, so let's break it down again. See if we can take out any common terms. 3 times 5, nothing can come out. No common factors in all three terms, so let's reassemble 2x squared plus x minus 15. 15 is not a perfect square, here it's 2, so let's try and factor using the x game. So make our x. AC goes on top, B goes on the bottom. So AC is -30, and B is 1. So the factors of 30, we have 30 times 1, we have 15 times 2, and 6 times 5. I guess 6 times 5 works. Okay, so 6, 5. So the sum is positive, the small number is negative. So these are the two terms we're going to use to make this a polynomial that can be factored by grouping. So we're going to have 2x squared plus 6x minus 5x minus 15. Okay? Now we're going to break it down the center and factor by grouping. Break it down the center. All right, to factor by grouping, we're going to break down everything. Make sure that we can take out the common factors with ease. So we have 2 times x plus 2 times 3 times x on the left side of the partition minus 5 times x minus 3 times 5. Okay? All right, on the left side, we will take out an 2 and an x, and then a 2 and an x. So we'll have 2x times. If these 2x and the 2x are taken out, we'll be left with x plus 2. Okay? X plus 3. X plus 3. All right, and then on the right side, always bring down the middle sign, minus. We can take out a 5 and a 5. If we take out a 5, we'll be left with x plus 3. Notice anytime you take out a minus, this middle sign here changes to the opposite, which is a plus. These two quantities are identical, so we're looking good. So pull them together. It becomes x plus 3 times 2x minus 5. So we're going to reinsert that as the right denominator. Okay? So we're going to have x plus 3 times 2x minus 5. Okay? All right. Now, let's see. We can now find the LCD with ease. We can see that x plus 3 is common to both denominators. X plus 3 is common here, and x plus 3 is common here. But the goal is we need identical denominators, so we need to resolve the differences. This has a 3x minus 1. This needs a 3x minus 1. So we're going to multiply by 1. The variation of 1 we're going to use here is 3x minus 1 over 3x minus 1 on the left side. And on the right side, we need a 2x minus 5. So on the right side, we're going to multiply both numerator and the denominator by a version of 1, namely 2x minus 5 over, for it in here, 2x minus 5. Okay? All right. So now we're going to resolve the numerators. So on the left side, we just distribute across the top. And on the right side, we're going to FOIL out across the top. Okay? So let's shift our attention to the left side on the top. 2x is distributed to 2x and the negative 5. All right? So 2x times 2x is 4x squared. And then 2x times 5 is negative 10x. With the denominators alone, 2x minus 5 times 3x minus 1 times x plus 3. Minus. On the right side, we're going to go first, outer, inner, last. Here, so when we do first, we have 15x squared, outer, minus 5x, inner, plus 3x, last, minus 1. Okay, so we just pull this out first, outer, inner, last. Okay, divided by, let me rearrange these products on the bottom so it's identical with the one on the left so we don't get confused. 2x minus 5 times 3x minus 1 times x plus 3. Okay, all right, let's bring it down. The left side cannot be simplified any further, so 4x squared minus 10x divided by the factors. We write the factors, which are 2x minus 5 times 3x minus 1 times x plus 3. And then on the right side, we can simplify, right? So minus 15x squared cannot be combined with any like term, so let's leave it alone, 15x squared. 5x minus 5x plus 3x is negative 2x minus 1. And that whole thing will be divided by the identical denominator, which is same as the one on the right. So we can just copy it over. 2x minus 5 times 3x minus 1 times x plus 3. Okay? All right. Now we can now combine them. Since we've simplified them independently as much as we can, write them as a common fraction. The denominators are going to be 2x minus 5 times 3x minus 1 times x plus 3. And then 4x squared minus 10x. Now notice we have a minus here again, so this minus should be distributed to the first and the second and the last term. Okay, so if I distribute the minus, what it's going to do is it's going to take the opposite of all the signs. So we have negative 15x squared plus 2x plus 1. Okay? All right. Now let's simplify by combining like terms. Let's rewrite the denominator first. Since we are not doing any work with that, just write it down. So the denominator is 2x minus 5 times 3x minus 1 times x plus 3. Now we'll start assembling like terms. So let's start with the squares first. So 4x squared and 15x squared. Let's use the green dots to identify it. If I combine these two, I will have negative 11x squared because the signs are different. We subtract and keep the sign of the bigger one, which is negative 11x squared. Next, we're going to combine 10x and 2x. So we combine negative 10x and 2x, signs are different, subtract and keep the sign of the bigger one. Your like terms probably have the same degree. So we have negative 8x. And then last but not the least, we combine, the constant is by itself. So we don't even have to combine it with anything. Okay? So the constant is by itself. So we just put the positive 1 over here. So there goes the answer, negative 11x squared minus 8x plus 1. That's the final difference of those two rational expressions. All right? So thanks so much for taking the time to watch this video clip. If you please subscribe to my channel by clicking up above here. You can also share this video with your friends via Facebook, Twitter, or Google+. For more clips, come on Microsoft.com. Thanks again and have a wonderful day.